So we got to continue where we are. These ones have no calculator, so you don't need your calculator out. Okay, and so the way this works is sometimes we have a cos compression. Notice that we have cos 2 theta equals negative 1/2. So how would you think to solve this? How would you think to solve this? Well, it's no calculator. Well, negative 1/2 is a cos value on the exact cos value on the unit circle. So how do you think you'd solve this? Okay, so the tendency for students to do is to get rid of this 2 right away. And that would be a mistake. So the thing that you have to think about is this is actually attached all together. You can't just take the 2 part out of it. Okay? So this is when I get my fancy little pen out and I use this happy face here and I say this is cos of happy face. Oops. And so if this was cos of happy face, how would I solve what cos of happy face is? Let's move this over. What would happy face equal? I'm sorry? A frowny face. No, I mean angles. If cos of some happy face equals negative 1/2, where was cos negative 1/2 on the one revolution of the circle? I'm sorry, quadrant 2 and 3. So where? Use your hands. It's one of the 60s, so pi over 2 pi over 3 and 4 pi over 3. And because it says it's on, like this is an infinite number of solutions, yes, it would be plus 2k pi. Just relax. Okay, so obviously we're not solving for smiley faces. What does the smiley face, oops, what does the smiley face actually represent? Cos 2 theta. So that means what we just found was 2 theta. Okay, so the reason why I do the smiley face is you're going to get this question, you're going to go, oh, I remember Mrs. Ramsey saying, don't divide by 2. Oh yeah, there was the smiley face trick thing. And then this is how you're going to remember how to do this question, right? Okay, so 2 theta. So essentially what I did is I inverse cos both sides, right? And so I got the answers for inverse cos of negative 1/2 to be these solutions. But when I inverse cos this side, I was left with the 2 theta, right? So how would I go from 2 theta to theta? Now, we would divide by 2 to get rid of the 2, right? So what's 2/3 divided by 2? No. When we divide, we're dividing, it's, what is it? Yeah, it's pi over 3, very good. And we're not just dividing this one by 2, we also have to divide this by 2. So what would we get? Plus k pi. And what would we get for the second solution? 4 pi over 3 divided by 2. Think about a picture of 2 pi over 3. That's how you should be thinking about dividing. Think about it, like, forget about the pi for right now. If you had 2/3 of a circle filled in and you divide it in 2, what would you have filled in? 1/3 of the circle. You know what I mean? It's not like hard math here. You just got to think about this logically. Same with 4/3. If you have 4/3 filled in, well, I guess you'd have, 3 pieces filled in and another piece over here, and you divided that into 2, you would have 2/3 pi left, right? Anyways, and so k is an element of integer. So this represents, again, this window is from 0 to 2 pi, so you see this is pi over 3, 2 pi over 3, and then a pi later from pi over 3 is 4 pi over 3, and then this would be 5 pi over 3, and so on and so on and so on. Okay. So let's go to the next question here. Again, this is a visual. Do you see how many x-intercepts there are? Infinite, right? So how are we going to figure that out? Well, if the equation is y equals cos 3x, how do I solve for x-intercepts? set y to 0. So 0 equals cos of 3x. Okay, so then again, this is the happy face. Sometimes, you don't want to draw a happy face, but just draw a circle around it, forcing you not to divide that 3 out of there so early, okay? So, where is cos 0? Where is cos 0? Cos is your x. Where is your x 0? Pi over 2. Yeah, pi over 2, 3 pi over 2, 5 pi over 2. So it's the odd intervals of pi over 2. Or you could say, if you look at it this way, if you have it in this spot and then this spot over and over and over again, if you start at this spot here, what would you have to add to get to this spot here? K pi, very good. So this is pi over 2 plus k pi. And if you were to write it as pi over 2 plus 2k pi and 3 pi over 2 plus 2k pi, that wouldn't be wrong. It's just you're kind of more redundant in your answers. So, of course, k is an element of the integers. So, what is x going to equal? I have to divide this by 3 now. So it's pi over 2 divided by 3. Think about the picture of a pi again. Again, you can use division, but I want you to think of this pi over 6. Yeah, you have half a circle filled in, and you have to fill that half a circle, cut it into 3s. So how much of the whole circle do you have? You have 6s, right? So pi over 6 plus, and what would this be if you divided by 3? K pi over 3. Okay, k is an element for the integers. That does not look like a k. Okay, perfect. Let's keep going here. So sometimes they actually give you a domain that you have to answer your question in. Again, I would still do it as a general solution and then have my final answer, and I'll show you why in a second. Okay, so we have to solve that sine pi x equals 0. So again, here's my kind of little, section that's fused together. So I have to undo the sine by doing inverse sine. If I inverse sine of 0, what is that? Where is your y value 0? I hear pi. That's not the only spot. Yeah, 0, pi, 2 pi, 3 pi, 4 pi. How do I write that? Every pi. K pi, yeah? I think I heard that, K pi. Okay, so how do I get rid of and get what x is? Well, I have to divide by pi to both sides. So what's x equal to then? K. Remember, k is an element of integers. What does that mean? This is where you truly have to know. Huh? Well, what are integers? I'm sorry? The whole numbers, but also negative whole. We don't really have whole numbers that are negative. Okay, so that means I need to list all the integers that are in this domain for my final answer. So, who can name it for me? Yep. Therefore, I'm summarizing. This is my final answer now. You should see this in chemistry class, I think, the therefore. Oh, in math class? Good math teachers. Okay, therefore, x equals, what is x going to equal if it's the integers between -3 and 3, and not including -3 and 3? Who can give me my first one, the least one? -2, then what? -1, then what? 0, then what? Then what? 2, then what? That's it. That's right. That's all you do. Well, that's only when x equals k, right? And I have to have my answers between -3 and 3. So, moving on. Sine squared 2x plus sine 2x equals 0. This would be the same thing as a squared plus a equals 0. How would you solve something that looks like that? How did you do that last year in grade 11 pre-cal, or last semester? No, you do not do that. Why do you not divide out the a? You take out the a, you factor out the a. I like those wordings better. I don't know if that's what you meant. Yes, you did. And then you're left with what? A plus 1 equals 0. And this wasn't a factor here. So then what did you do then? This is the zero product property. So that means I can set those factors equal to 0 and solve at that point, right? If I go back to this, I have sine, and I'm going to write it this way just so you can see that this is the same thing. I don't even need a bracket there, but I want you to see that sine squared 2x is the same as sine 2x, the whole thing squared. So what am I going to do here? I'm going to factor out a common factor, which is sine 2x. And what am I left with when I factor that out? Sine 2x plus 1. Very good. So that means, again, using the zero product property, that sine 2x equals 0, and sine 2x plus 1 equals 0, which means sine 2x equals -1. Yes? Okay, so again, these are fused together, right? So now I'm going to come up with, where's sine 0? Where's sine 2x, sorry, where's sine, the y value, 0? We just finished doing this. Just pi and 2 pi? And 0? K pi, that's right, K pi, where k is an element. I'm going to put that over here. K is an element of integers. Where is sine -1? 3 pi over 2, and where else? Every revolution after that, in that spot, that's the only spot. Okay, and you might say, well, wait a minute there. The question said you're only supposed to list the answers from 0 to 2 pi. That is correct. I highly advise that when you see something with this, with the 2x, that you actually do it as k pi's and then do your dividing and then do your final answer. And I'm going to show you why in a second. So if I get 2x equal to k pi, what's x going to equal? K pi over 2. And what's this going to equal? 3 pi over 2 divided by 2. 3 pi over 4. And what's 2k when you divide by 2? K pi. So plus k pi, where k is an element of integers. Remember that this integer list is ... -3, -2, -1, 0, 1, 2, ... The whole list of integers, right? So what we have now established, not the final answer yet, because I need to list all the solutions from 0 to 2 pi, is now I need to plug in the k's and generate my list here. So therefore, x equals, you ran out of room, just do it on the side there. So what would the first one that I should put in logically if I'm starting from 0 to 2 pi? Does it make sense to put in, say, -3? No. So what was the logical thing to sub in? 0. So we're going to put 0 in for k. What do we get out of this conglomerate here? We get 0. Then I'm going to put the next one in the list, which would be 1. 1 goes in there. What do I get? Pi over 2. Then I'm going to put the next number in here, which is 2. What do I get? Pi. Then I'm going to put the next one on the list. What do I get? 3 pi over 2. And then I put the next one on the list. What do I get? 2 pi. And then I'm done for the k pi over 2 part, right? Because 2 pi is as high as I'm supposed to go, right? Okay, so now I'm going to put it in the list, the 0 again. 0 goes in for k. So what do I get as my first one? 0 goes in for this k right here. So I get 3 pi over 4 plus 0 pi. So what do I get? No, I don't get 0. I get 3 pi over 4. I'll say that again. I'm putting 0 in for the k. There's no k in the 3 pi over 4. So it's 3 pi over 4 plus 0 pi. So it's just 3 pi over 4, right? Okay, so I'm going to put 1 in for k. So 3 pi over 4 plus 1 pi. 1 pi would be 4 pi over 4. So what's 4 pi over 4 and 3 pi over 4? Huh? Yeah, 7 pi over 4. Okay, then if I put 2 in there, I'm already adding 2 pi to 3 pi over 4, so I'll be too high. Okay, so this is my final answer, and I'm going to show you why doing it with the general formula is better than just listing it. So just an aside here, if I were to solve this and I get sine 2x equals 0, so the same method, and sine 2x equals negative 1, and I only list answers from 0 to 2 pi, let's do that. So 2x would be, where would be sine 0? And we're going to list it from 0 to 2 pi. 0, pi, 2 pi, yeah? Okay. And where is sine 2x equal to negative 1? 3 pi over 2. Okay. Now, what do I have to do here? I have to divide by 2. So what do I get when I divide 0 by 2? I get 0. What do I get when I divide pi by 2? Pi over 2. What do I get when I take 2 pi and divide by 2? Pi. What do I get when I divide 3 pi over 2? 3 pi over 4. Now let's compare my answers to the answers you were supposed to get. What do you notice? We're missing a bunch, not just one. We have this one, this one, this one, and this one. We're missing half the answers essentially. Okay, so now why is that the case? Why is that? Why did I only, if I did it directly like that, why am I missing half the solutions? Well, I'm saying you can do it this way, but do it with caution. Okay, so here's the thing. Do you see when I listed it at this step, I listed it from 0 to 2 pi. And then when I divided by 2, I essentially divided my domain in 2. Do you see? This is why I'm only getting my answers from 0 to pi. So if you do it this way, it's not necessarily wrong. The only glitch you have to do is you need to list the answers from 0 to 4 pi, because when you divide by 2, then your final answers will be from 0 to 2 pi. This is why I say do it this way, because then you can just string along until you've got all the answers, right? I see way too many mistakes when people do it this way. I show you this, but I would say this is probably the better way. But again, make sure you don't leave your answer in k-pi's if it's saying a domain is from 0 to 2 pi, because you will get a full mark error.